everyone. Even though it's afternoon, good morning. Even though it's evening, good morning. This is Jella May T. Torres, and I am going to introduce to you our topic for this video presentation. So our topic is all about additive and multiplicative inverse using the table. But before that, let me introduce first our table of contents. We have here the introduction, content and concept of additive and example, content and concept of multiplicative inverse and example, application, reflection, and the references. So this is our objectives. After the discussion, you ought to be able to comprehend the content and concept of the modular additive and multiplicative inverse, find the two certain operations, and understand how to apply the additive and multiplicative inverse in real-life scenarios. So before proceeding to our main topic, let me introduce first what is modular arithmetic. Kay gamit kay ni siya in solving the additive and multiplicative inverse. So modular arithmetic is a system of arithmetic for integers where numbers wrap around upon reaching a certain value or the modulus. So the notation sa modular arithmetic is x is equal to y mod n. So mo ni ang atong examples. 25 mod 5 is equal to 0 and 25 mod 7 is equal to 4. So, bali, ang x diriya is the dividend. Then, ang atong n, kay amo ang divisor, and y is the remainder. So, diriya sa atong example, ang 25 nato is mao ang atong dividend, and ang 5 is our divisor. Then, ang 0 is ang remainder. So, wala siya remainder. Kay pag i-divide nimo ang 25 sa 5, kay wala siya remainder. Then, sa our second example, kay walay naay remainder, pag i-divide nimo ang 25 sa 7, kay 21 man dapat ang answer, then plus 4 is 25. So, muna daraang sa modular arithmetic. Okay, so let us proceed to our main topic, which is the additive and multiplicative inverse. The first one is the additive inverse, which will be discussed by Ms. Ravi Jane Agni.
Ravi Jane Agni. So this video is all about the concept and content of additive inverse using the Z table. So first, what is additive inverse? Sa word nga additive, so it means it is characterized by addition, an additive process having the property that the function of the union or sum of two quantities is equal to the sum of the functional values of each quantity. In mathematics, the additive inverse of a number is defined as a value which, on adding with the original number, obtains the value of 0. Additive inverse, a number that when added to a given number sums 0. Example, the additive inverse of 6 is negative 6. So, the opposite of a number is its additive inverse. It is any number that added to the original number give the result as 0. In additive inverse, 0 is the rational number which is equal to its additive inverse. So next is, in modular arithmetic, the modular additive inverse x is also defined the number such that the formula is a plus x is congruent to 0 mod n. So in mathematics, the additive inverse of a number a is the number that when added to a, it sums up of 0. And kanang number is also known as the opposite, sign change, and negation. And the additive inverse of x is simply the number which when added to x is simply yields the additive identity, and the additive identity is 0. So let's proceed to the next topic, the example of additive inverse using the table.
May Aldave, and I'm going to discuss the additive inverse using the Z table. So here are the example of additive inverse using the Z table. So what are the numbers are less than 3? So pause this lecture video for a while, then try to think what are the numbers are less than 3. Okay, balik tanong. So, ang numbers nga na sa less than 3 is 0, 1, and 2. So, kay additive inverse man atong gamit is, so mag-plot ta diri og, um, addition sign. Then, plot lang nato ang 0, 1, and 2. Then, diri afsad na, paubos, 0, 1, and 2. So, karon i-add na nato siya. So, 0 plus 0 is equal to 0. Then 0 plus 1 is equal to 1. Then 0 plus 2 is equal to 2. Then diri asad, same process gihapon, 1 plus 0 is equal to 1. Then 1 plus 1 is equal to 2. Then 1 plus 2 is equals to 3. Then 2 plus 0 is equals to 2. Then same here gihapon. Then para makuha ang remainder is plot gyapon nato diri ang addition sign. So 0, 1, and 2. Then diri para makuha ang remainder, diba? Diri 2 plus 2 is equals to 4. So 3 mo 0 is equal to 0. So same here, 0 gihapon kay 3 mo 0 is 3 mo 3 rather is 0 man siya.
Na-explain naman sa inyo ha, unsaon ang additive inverse using the table. So, proceed na po ta sa example niya para mas masabtan ninyo siya. Okay, so, ang first example man nato is kaning Z3 table. So, mo ni siya ang solution. So, ang first nimo hinumduman is ang notation sa katong modular arithmetic, which is ang katong x is equal to y mod n. Para makabalo ka sa format kung asa nimo ipamutang ng mga numbers. So, dari ang kaning una nimo nga ang una nimo nga himuon is pangitaon nimo ang value sa x nga inag-add nimo sa 1, then inag-divide nimo sa 3 is wala siya remainder kay ang goal diri as additive inverse kay walay remainder. So, mangita kag value nga inag-add nimo is inag-divide is wa siya remainder. So, kung tan-awon nimo siya diri sa table, na explain naman to kaganina, inagtan-aw nimo diri sa row, kantahay kaning sa 1, tapos ang di ba 1 plus x man ni 1 plus x is equal to 0 mod 3. Then pangitaan nimo kung unsa ang value dara sa x, kung unsa imong pwede ma-add dara nga ang result, inag-divide nimo siya diri sa mode 3 kay 0 ang remainder. So inagtan-aw nimo diri sa table ang sa row ang kaning 1 diri nga value kay natunong man siya diri sa 2, which is wala siya remainder 0. So it means ang ibutang nimo sa value sa x is 2, then pag i-add man sad nimo siya 1 plus 2 kay 3, pag i-divide nimo 3 kay 0. So tama siya. Ang inverse sa kuan sa 1 mod 3 is 2. So mo na siya daraa. Then ang sunod is ang kaning sa 2. 2 plus x is equal to 0 mod 3. So mangita na pug kag value sa x nga inag-add nimo then i-divide sa 3 is 0 ang remainder. Then dira makita naman sad nato siya sa table nga ang kaning sa first ang kaning sa row diri kaning sa 2, then natunog man siya diri sa column nga kaning ang nakabutang is 1. It means ang kaning ibutang nato sa value sa x is 1. Then pag i-solve nato siya 2 plus 1 is equal to 3 gihapon. Then pag i-divide na pud nato siya 3 kay 0 ang remainder. So tama siya. So muna diraa, so ang inverse diraa sa 2 mod 3 is 1. So inganaon lang siya pag-solve ang sa additive inverse diriya sa Z3 table. So next is na-explain naman sa inyo ha unsaon ang additive inverse using the table. So proceed na pud ta sa example niya para mas masabtan ninyo siya. Okay, so mag-proceed na po ta sa another example. Then, mubalik si Miss Aldave para i-explain na po niya diriya sa table.
Hala. So, here are the example of additive inverse using the Z9. So, ganina kay ano man to, kining Z3. So, karon mas nagapad ako taong number. So, sa Z9 na ta. So, here are the numbers are less than 9, 0, 1, 2, 3, 4, 5, 6, 7, 8. So, here are, so nag-plot na putad diri og addition sign, then plot na to diri ang last katong mga number nga less than 9. So, 0, 1, 2, 3, 4, 5, 6, 7, 8. And also here, 0, 1, 2, 3, 4, 5, 6, 7, 8. So, ganina, same lang yapon sila sa katong Z3. So, ano lang, mas nagapad ako lang taog number na. So, Z9 table ang ato ang gamit. So, karon, so, if ano na nato siya, i-add na nato. 0 plus 0 is equals to 0. 0 plus 1 is equal to 1. Then, 0 plus 2 is equal to 2. Then, 0 plus 3 is equals to 3. Then, 0 plus 4 is equals to 4. Then, 0 plus 5. Then, 0 plus to 5. So, same lang yapon siya diri, plus lang nato siya. Then, diri apod, plus lang nato. So, nandun sa maabot na diri sa 8 plus 8 is equals to 16. So, diri para makuha na to ang iyang remainder. So, same process. I-plot lang na to ang addition sign. Then, 0, 1, 2, 3, 4, 5, 6, 7, 8. So, same here. Plot lang yan po na to. So, para makuha na to ang iyang remainder. So, as you can see, puro ang nakapaana siya, naka-0 ni siya tanan diri. So, kay ano man, 9 para diri 1 plus 8 is equals to 9. So 9 mode 9 is equals to 0. So same here, 2 plus 7 is equals to 9. Then 9 mode 0, and 9 mode 9 rather is equals to 0. So same here lang yapon, antod sa maabot na punta diri asa 8 plus 1 is equal to 0. Kay 9 mode 9 is equals to 0.
Nasad ko para i-explain sa inyo ha ang solution diri sa ato ang second example sa additive inverse, which is ang Z9 table. Okay, so ang first nato himuon is ingatoon lang gihapon siya, hinumduman ang notation sa modular arithmetic. Mangita gihapon ka og value sa x nga nag-add nimo, then i-divide nimo sa mode 9 is 0 ang remainder. So na-explain naman ang pagkuha sa unsa niya sa value using the table. So tan-awon na lang nimo diri sa table kung unsa ang value sa x. Example kaning sa 1 plus x, ang kaning 1, ang kaning diri adyo ka sa row magtan-aw. Tapos kanang para makabalo ka kung unsa ang value sa x is tan-aw nimo kung asa natunong ang kanang 0 nga remainder diri sa column niya. So na ang kaning 0 nga remainder diri sa row sa diri sa 1 is natunong man siya sa 8. Then pag i-solve nimo 1 plus 8 is equal to 9, then i-divide nimo sa 9 is 0 ang remainder. So mo na siya ang value sa x dara ang additive inverse niya. Then ang next is ang diri na pud sa 2 plus x. Then pangitaon gyapon nimo kung unsa ang value sa x kay nag-add nimo sa 2 is ang kuan ang answer kay kanang wala siya remainder i-divide nimo siya sa 9. So ingatoon gyapon nimo siya magtan-aw lang kadara sa row niya, then pangitaon nimo kung asa dapita ang 0 dara niya inagtunong nimo dara sa column is mo na siya ang value sa x. So ang inverse of 2 modulo 9 is 7. Kay nag-add man nimo sa 2 plus 7 is 9, then divide 9 is 0 ang remainder. Okay, so diri na punta sa 3 plus x equals 0 mode 9. So makita man dara sa table nga ang natunong dara sa nasa row nga 3 nga ang value sa x niya is 6. Kay nag-add nimo sa 3 plus 6, then divide sa 9 is 0 ang remainder. Therefore, the inverse of 3 modulo 9 is 6. Then, dirian na punta sa 4 plus x. So, ang imo ang i-add sa 4 diria para inag-divide nimo sa 9 kay 0 ang remainder is ang 5. Makita nimo siya dara sa table kung giunsa. Makita man nimo dara na nakatunong ang 0. Then, i-add nimo siya, then i-divide, so 0 ang remainder. So, the inverse of 4 modulo 9 is 5. Ingatuan lang nimo siya hantod maabot ka dara sa 8. 8 nga unsa kay kuan man na siya kana 0 to 8 man na, then ang kaning diri sa solution gipakita kay hantod sa ano lang sa 4 plus x. Then ingatuon lang nimo siya pagkuha kung i-solve pud nimo sa 5 plus x, 6 plus x, 7 plus x ug 8 plus x. So ingatuon lang ang pag-solve sa Z9 table. Okay. So, mao lang to ang sa additive inverse ug unta na nasabtan ninyo kung unsa ang kuan niya ang way para makuha nimo ang value sa x. So, our next main topic is all about multiplicative inverse, which will be discussed by Miss Katrina Tibog.
So again, I am Katrina G. Tibog, so I will be discuss the multiplicative inverse using the Z table. So first, what is multiplicative inverse? In modular arithmetic, the modular multiplicative inverse of an integer a is an integer of x such that the product ax is congruent to 1 with respect to the modulus m. The standard notation of modular arithmetic, this congruent is written as ax is congruent to 1 mod n. So, the multiplicative inverse of a is denoted by the a raised to the power of negative 1 or 1 over a. In other words, when the product of two numbers is 1, they are said to be the multiplicative inverse of a modulo m.
So if M exists if only A and M are co-prime. If the modular multiplicative inverse of A modulo M is exists, the operations of divisions by the modulo M can be defined as multiplying by the inverse. So 0 has no modular multiplicative inverse, so the theorem tells us that Fn is prime, then Zn or non-zero is a field, hence every non-zero integers has a multiplicative inverse. So let's proceed the examples of multiplicative inverse that we'll be discussing of Kisha-Kate, Asuncion, and Wendell typing.
We have here the example of multiplicative inverse using the Z3 or the table for Z3. So here in our table, as you can see, Z3 or mode 3, all positive numbers that are less than 3, we have to ibutang na to siya diri sa ato ang table. So those numbers are 0, 1, and 2. So wala na ilabot diri as 3. It's because numbers lang, positive numbers nga less than kay 3. So that's kanini sila is 0, 1, and 2. The same pod siya diri ang part 0, 1, and 2. So in multiplying the numbers, we have to multiply the row times column, row and column. So 0 times 0 is 0, 0 times 1 is 0, 0 times 2 is 0. The same po diri as sa ikaduhang row. Ang 1 times 0 is 0, 1 times 1 is 1, and 1 times 2 is 2. The same for diri sa 2. 2 times 0 is 0, 2 times 1 is 2, and 2 times 2 is 4. So, inganaon lang siya pag times sa kaninga table. So, our next table is the remainder or katanang kuan multiplicative inverse nga ang kaning naa diri is nga remainder sa kaninga number. So, ang una nato kani 0 times 0 is 0, and we know that 0 mode 3 is equal to the remainder we have 0. The same po diri 0 times 1 we have 0. So 0 mode 3, the remainder is 0. Same po diri 0 times 2 is 0, and 0 mode 3 is 0. So sa 1 po, 1 times 0 is 0, and 0 mode 3 is 0. And 1 times 1 is equal to 1, and 1 mode 3 is 1. So 1 divide 3, we have the remainder of 1. And next is 1 times 2 is 2. And 2 mode 3 is 2. Or the remainder, we have the remainder 2. And the same po diri 2 times 0 is 0, and 0 mode 3, we have the remainder 0. The same diri apod sa 2 times 1 is 2, and 2 mode 3 is equal to the remainder of 2. And 2 times 4, 2 is equal to 4, and we know that 4 mode 3 or 4 divide 3, we have the remainder 1. So as you can see in our table, we have 2, 1 or duha ka 1. So that is the the concept of multiplicative inverse. Using the Z table, we have the remainder 1 nga pag i-times na to ang i-time ang itatag value ni x nga pag i-times na to sa sa kaning x, we have the remainder 1 in Z3 or in modulo 3. So next is dara. As you can see, we have the remainder 1 in our table. So mao ni ang ato ang For example, kani siya mao ni ato ang 2x mod 3 or 2x mangita ta og number nga pag i-times nato sa kani nga for example kani ato ang x wa pa ta kabalo kung unsa ni nga value pag i-times daw nato ni siya diri is we have the remainder 1. So the concept of multiplicative inverse using the z table or the z3 sa z3 we have the remainder 1. So our so para masabtan pa nato we have the example to be discussed by Kisia Kate Asuncion.
So again, I am Keisha Kate Asuncion, and for this session, I will going to discuss on how to find the value of x using the z table. So 2x is congruent to 1 mod 3. So nakita na to sa table, ang nag-remainder of 0 is this part, kaning nga part. So which means nga ang ay kani na part. So 2, meaning si 2 ang ato ang x. So 2 times 2 is equal to 4 congruence 1 mod 3. So meaning pila daw ka 3 ang naa sa 4, which is 1, and naa siya remainder nga 1. Next is, so the inverse of 2 mod 3 is 2. So kanang 2 is the value of x. Next is 1x is congruent to 1 mod 3. So diri nga part is maoni nag-congruence, nag-result, ay remainder is 1. So which is 1 times 1 is 1. So 1 mod 3 is, yung remainder is 1. So 1 times 1 is equal to 1 mod 3. Sorry, pero that is 1. Sorry, that is not 3, but that is not 1. So 1 congruence 1 mod 3. So next is another example of z table. So mas higher ang atong i-give nga example, which is the z9 by Mindel by P. Okay, another example of multiplicative inverse using the z9 or complete the table for z9. So Mr. Terpin will discuss about.
Alright, so we have here the table for z9 or the modulo 9. So as you can see, pareha ganiha akong giingon nga ibutang nato ang mga numbers nga under kang 9 or all positive numbers nga less than kang 9. So 0 hangtod 8 lang siya. 0 up to 8, and the same goes to diri as sa pikas 0 hangtod 8. So in multiplying these numbers, itong pareha ganiha row times column. So the 0 times 0, 0, 0 times 1 is 0, the same to diri as 1 times 0 is equal to 0, and 1 times 1 is equal to 1, and 1 times 2 is equal to 2. So that's how you get the multiplication using the this table. So i-times lang nimo ang iyahang row sa iyahang column, z kani row and this column. So mao ni ang iyahang mga answers sa pag-i-multiply nimo. So next table is to find the remainder. To find the remainder for this or the remainder when we are multiplying two numbers, we got these remainders. So 0 times 0 is 0, 0 times 1 is 0, or 0 mod 9 is 0. The same po diri ang mga numbers. Times man nato siya sa 0 kani mga numbers, pag i-times sa 0, automatically ang iyang answer kay 0. And diri sa 1 times 1 is equal to 1, and we know that 1 mod 9 is we have the remainder 1. 1 times 2 is 2 and 2 mod 9 is 2 up until diri sa kani nga part. We say 1 times 8 is equal to 8 and 8 mod 9 we have the remainder 8. So diri ata sa kaduha ng sa 2. So 2 times 1 is equal to 2 and 2 mod 9 is equal to 2. The same lang na siya diri nga part. Diri is nausab na siya. Nausab na ang iyahang value. It's because when we multiply 2 times 5 is equal to 10 and we know that 10 mod 9 we have the remainder 1. When 10 divide 9 we have the remainder 1 and we the same for 2 times 6 2 times 6 is 12 and we know that 12 mod 9 we have the remainder 3. So the same process lang gihapon diri we get when we are multiplying these numbers we have the remainder 5 and 7. So diri pod sa sa 3 okay, sa 3 we have here that 3 times 3 or 3 mod 9 is equal to the remainder of 3. So nganong na kuan man siya diri 0. Nganong 0 dili 1? It's because when we multiply 3 times 3 is equal to 9 and we know that 9 mod 9 is equal we have the remainder 0. So the same process lang gyapon siya diri and diri na 0 gihapon siya. It's because 3 times 6 is 18 and we know that 18 mod 9 or 18 divide 9 is equal to 2 and we get the remainder 0. So the same process lang gihapon siya diri sa 4. Next, diri sa 4 we have 4, the same process lang gihapon. 4 times 1 is equal to 4 and we know that 4 mod 9 we get the remainder 4. And the same process lang pud siya diri and kani nganong nawani diri siya diri it's because when we multiply 4 times 7 is equal to 28 and we know that 28 mod 9 is we have the remainder 1 or 28 divide 9 we have the remainder 1. And the same process lang po diri sa 5 kani as you can see with natay 1 diri kay pag times nato ning 5 times 2 is equal to 10 and 10 mod 9 we have the remainder 1. So anaon lang siya no pagkuha sa mga remainders. The same process po diri sa kanina row. Kung diri sa 6 so dili na siya 1 no? It's because ngano gani it's when we multiply 6 times 3 kani 6 times 3 is equal to 6 times 3 is equal to 18 and we know that 18 mod 9 or 18 divide 9 is equal to 2 ug wala siya remainder 0 ang iyang remainder. That's why 0 siya diri nga part. The same po diri sa kani 6 times 6 is equal to 36 and we know that 36 mod 9 wala siya remainder or 0 iyahang remainder. So diri apod sa 7 we get kung ato siyang sundan tong process in multiplying and getting the remainder mao ni yung iyahang mga remainder. And we know that okay na siya 1 diri it's because 7 times 4 is equal to 28 and we know that 28 mod 9 we have the remainder 1 or 28 divide 9 we get this remainder 1. The same process po diri sa 8 pag imuha siyang i-multiply and getting the remainder, we have this remainder. So, as you can see in this table, naatay mga color coding or naa siya mga color, diba? So, kani siya mga color coding is naa ni siya kapareha. For example, kani siya diri nga row 0, 1, 2, 3, 4, 5, 6, 7, 8 is pareha siya color diri sa ubos. It's because ang iyahang diri 0 hangtod 8 gimura gibali lang diri sa pikas or diri nga row. Bali iyaha lang gi reverse. So, di ba? 0 to 8 to siya diri diri pod is 8 hangtod 1 ana or diri 1 hangtod 8 diri sa pikas gi-reverse lang nahimo siyang 8 up to 1 8 7 6 5 4 3 2 1. The same process po siya diri so bali mura siya og pattern niya. So as you can see 2 4 6 8 1 3 5 7 is pareha siya diri pagbalihon 7 5 3 1 8 6 4 2. So pag balihon siya, di ba? Kay 7 diri ang last. So diri ang nauna is si 7 na. Sunod si 5, sunod si 3 and up until 2 2. So naa siya pattern no bali reverse or kanang kabaliktaran lang ani nga kuan is nasa ubos. So the same process lang po diri sa kaning nga row. So nauna diri is si 3603 na 6036. Pag imuha na siyang balikon, mahimo siyang mauna si 6, sunod si 3, sunod si 0, 6, 3, 0, up until 3. So, the same process lang po diri pag imuha na siyang, kanin siyang pattern, 4, 8, 3, 7, 2, 6, 1, 5. Pag imuha na siyang balikon, mauna na diri si 5, 1, 6, 2, 7, 3, 8, 4. So, mao ni ang ihang naka-nice diri it's because naa siya pattern. So naka-reverse lang ihang pattern kung unsa diri mao pud iyang kabaliktaran diri So that's how are you going to get the remainder using the z table, the multiplicative inverse table. So now for the example of this in finding the value of x using this table, Kisha Kate Asuncion will discuss to you the example.
Hello, I am back again, and now we'll proceed to the solution of finding the x using the z table. So this is the remainder, and first we have 7x is congruent to 1 mod 9, so 7x, this is the 7, so ang iyang remainder is 1, so ang atong x is 4. So 7 times 4 is equal to 28, congruent to 1 mod 9. So meaning, kung dali siya masabtan, pila ka 9 ang naa sa 28. So, then naa siya nabiling na remainder, which is ang 1. So the inverse of 7 modulo 9 is 4. Next is the 2x is congruent to 1 mod 9. So 2 here, so ang remainder is 1. So meaning, so 2 times 5 is equal to 10. So pila ka 9 ang naa sa 10, which is isa lang. So 1 times 9 equal to 9, then ang remainder ng 1. So the inverse of 2 modulo 9 is 5. And the last is 8x is congruent to 1 mod 9. So 8 remainder 1. So 8 times 8, it is equal to 64. So meaning, pila ka na nasa 64, then na ay remainder na, which is 63, then na ay remainder na 1. So the inverse of 8 modulo 9 is 6. Next, the last, there is last pa diyan. The last is 1x is congruent to 1 mod 9. So 1, then here 1, yung remainder is 1, then na ay
So 1 times 1 is equal to 1. So 1 is congruent to 1 mod 9. So, para masasabtan, ang multiplicative inverse is dapat na siya yung remainder nga 1, which is kani, 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 and kani, and kani. So, mao ni ang example sa additive and multiplicative inverse using the Z table. And next, mag-proceed ta sa the application of additive and multiplicative inverse by Josie Suson and Teresa Ortolita.
Okay, so again, I am Clarissa Artolita. So my topic is all about the application of additive and multiplicative inverse. So I assigned to explain the application of additive inverse. Okay, so as we all know, so additive inverse is A plus B is congruent to 0 mod n. So I have here an example. So the additive of 5 modulo 11. So 5 plus negative 5 is equals to 0. So in additive inverse, the positive or any sign that we are going to use in additive inverse, we change it. So instead of positive 5, we use negative 5. So in this case, 5 plus 6, so our additive inverse is 6, so it equals to 11. So 5 plus 6 is equals to 11, mod 11, and equals to 0 modulo 11. So that is our additive inverse. So I have here another table that will explain on how the additive inverse to be added. So find the additive inverse of all positive integers less than 5 under addition modulo 5. So we focus on number 5. So I have here the integer 1, 2, 3, 4. So that is our A. And our B is the additive inverse. So the additive inverse of 1 is 4. The additive inverse of 2 is 3. And the additive of 3 is 2. And the additive inverse of 4 is 1. So A plus B, so our, in this case, 1 plus 4 is equals to 5. Then 2 plus 3 is equals to 5, so on and so forth. So our remarks is 1 plus 4 is congruent to 0 modulo 5. So here in the table, we look for we fill in the table using addition modulo 5. So I have here the 0, 1, 2, 3, 4, and in the upper side is the remainder. So in this case, for the additive inverse or additive identity of 4 is, the additive inverse of 4 is 1, because we look up to the congruence of equals to 0. So the additive inverse of 3 is 2. Then the additive inverse of 2 is 3. And the additive inverse of 1 is 0. So that's all, and thank you.
So good morning everyone, I am Jessie de la Cruz Suson. Today I will discuss the modular multiplicative inverse, the application. So, multiplicative inverse. Modular multiplicative inverse are used to obtain a solution of a system of linear congruence that is guaranteed by the Chinese remainder theorem. So this one is modular multiplicative inverse is a functional not just academically but in a real life scenarios as well. So on many machines, particularly those without hardware support for division, division is a slower operation than multiplication. So this approach can yield a considerable speed up. The first step is relatively slow but only needs to be done once. So the last one is let's go to the next topic is the application is given by the icolysis. I am icolysis and I will discuss the reflection. So these inverse operations have important reflections in our daily life. It also is an essential aspect of number theory. We can see its implementation in various aspects, including balancing finance, adjusting recipes, and calculating percentages. Thus, having a strong foundation in this concept can improve our mathematical understanding. This concept can enhance our numerical comprehension and help us in making well-informed decisions in our day-to-day lives. So, ang additives and multiplicative inverse kay importante yun siya sa atong daily life kay natong ginagamit sa pag-compute. Example kay banking finance. So, ang additive inverse ay ginagamit nato ni siya sa balance financial transaction. Similarly sa multiplicative inverse, nato na sa pag-compute sa interest rate and currency exchange rate. So, muna ginagamit nato. And sa adjusting recipe, ginagamit nato sa pag-adjust the quantity of the ingredients in a recipe by adding or multiplying by their inverse. So, sa calculating percentage, ginagamit nato ni ang additive and multiplicative inverse kay ang calculating percentage represent the opposite values operations. That's why we need to use the additive and multiplicative inverse to find a specific percentage of a given number. So, dili lang kani daghan pa na mga kuan na magamit nato ang additive o multiplicative inverse sa atong pag-adlaw-adlaw.
So, good morning once again, everyone. I am Legia Sikimia, and as we listen the discussion, here are the references of our topic presentation. And if you wanted to broaden your understanding about our topic, you can browse and explore using these references we provided. Furthermore, I would like to express my sincere appreciation to each and every one of you for taking the time to join us today. Hope you learned something from our discussion. Thank you for listening, and God bless us all.